Assalamu alaikum friends, I hope you are alright. Today we are going to look at components of hydrograph, hydrograph analysis and the methods used for it. So the components of hydrograph are channel precipitation, direct runoff and base flow. Direct runoff is usually considered to be the sum of surface runoff, which is the rainfall water which is flowing above the surface of the ground, and interflow is the water which infiltrates through the soil to the groundwater. Base flow is the flow component contributed to channel by groundwater. This process is extremely slow as compared to surface runoff. And this is because surface runoff is free to move to the channel, while the groundwater has to infiltrate out of the soil so that it can reach the channel. That's why it is extremely slow process as compared to surface runoff. Hydrograph analysis. It means dividing total runoff indicated by the hydrograph into its components, of which direct runoff and base flow are more important. The separation of hydrograph components is done by one of the following three methods, which we are going to study today. The first method is straight line method. So let's consider a hydrograph as shown in this figure. From point A, draw a horizontal straight line which meets the falling limb at point B. Above line AB is the direct runoff and below this line is the base flow. The volumes of direct runoff and base flow are area under the curve, which may be calculated by any suitable method. The straight line method for separation of hydrograph has the advantage of producing an extremely long time base for the direct runoff hydrograph. The time base varies from storm to storm depending on the flow at the point of rise. It is a computationally easy method. The second method is fixed base length method. In this method, the surface runoff ends after a fixed interval of time after the peak of flood hydrograph. In the hydrograph shown in this figure, extend the point A on the curve to point D, which is vertically below the peak. Now draw a line from point B to point C on the hydrograph equal to a distance on x-axis given by the equation n is equals to AD raised to power 0.2. where n is the length of time in days and AD is the drainage area in square miles. This line will meet the falling limb at, say, point C. Join the point B to C by a line BC. Area below ABC is the base flow and that above it is the direct runoff. The third and final method is variable slope method. This method is based on the fact that if water rises in the stream, the water level in the stream becomes greater than the adjoining groundwater table level. As a result, the flow occurs from the stream to the groundwater and is stored there as bank storage. Refer to this hydrograph. Take a point A on the recession curve and the line AE by extending the previous recession curve. Point E is under the peak. Now take a point B on the recession curve and extend it backwards. Take a point C on the recession curve where the recession curve is changing the slope. This point is called the point of inflection. Draw a vertical line from the point C. It cuts the line drawn backwards from point B at the point D. Join the point E to this point D. Now the area under the line AEDB shows the base flow component. Hydrograph analysis by variable slope method varies from expert to expert due to different interpretations. So these were the different methods which we can use for hydrograph analysis. That's all for today. We'll meet in the next video. Till then, take care.